So let's welcome our one and only speaker today, Tim Scheuermann. He will talk about writing a Powerline prompt in Go. He is a plasmid on Twitter, the software developer in Berlin, one of our co-hosts here for this meetup. And he fell in love with programming 17 years ago and with Go itself in 2012.
Yeah, version 1 back then. Yeah, thank you for the introduction, Ole. I'm Tim. I'm a Go developer, mostly not professionally. I'm at work we are mostly using Python and Node, but privately I'm using a lot of Go and a little bit of tooling at work. Got my Go Go skills as well. So I'm half professional, I could say. This talk is about just a hobby project, so nothing too fancy. Yeah, I'll be talking about the writing a Powerline prompt in Go. And first, we should establish what is Powerline. You can see it in the screen. It's a status line that is in a particular style, like these arrows. You have probably seen them already. They are often used as prompts. There are implementations for a number of different terminals or different shells, better. They often display additional information. You can see this here with a Git branch. But there's also information about the Node version, for example, or your virtual environment for Python. Yeah. It was originally developed for Vim, for the text editor, as a status line at the bottom. And yeah, since then it has been expanded. What I'm not talking about is the Powerline Ethernet over electrical cables. That's also called Powerline, at least here in Germany. And yeah, I'm not using it. Once I start using it, I will have a talk about that too. When I can get Go to do something with it, maybe. Okay, so how it started. I came into contact with it because macOS made ZSH the default shell on in one of the earlier versions. It's been a few years now, and there is a well-known or the best-known implementation for Powerline in a prompt is for ZSH. So a colleague showed me. I had just one tiny little problem. That was the MacBook I was using. This is a simple picture, an illustration. It was a 2013 MacBook Pro with 8 GB of RAM. With all the Teams and Slack and Outlook, VS Code and a browser running, it was already slow and would take about 2 seconds, sometimes a little bit less, sometimes more, to display a prompt with the Powerline implementation, at least the default configuration in ZSH. The maximum I've got was in a Git repo with a lot of changes where it took almost 20 seconds, like 18 and a half seconds or something. I measured it. Yeah, so that's not how I can work. I guess yours the same. It's yeah, it's not it completely rips you out of your flow when you have to wait that long. So the only possible solution is to write it yourself in Go, of course. Back then, there are other implementations of Powerline in Go. I didn't know about them, but when I discovered them, I was like, I want to do it on my own anyway. So let's get started. It took me basically 5 steps to achieve this. And one of my goals was to remove a little bit of clutter. I could have just configured the Powerline for ZSH, but I just wanted a simple solution in Go. And I wanted to avoid calling external commands. That's one of the problems I think was that it was running through a multitude of commands trying to find if I was in a virtual environment, if I was in which node version I was in, or if I was in a node project or stuff like that. So just keep it simple. Step 1. Those power lines are based on patched font or patched fonts, plural. So you basically have those characters up here. Those are non-standard characters in most fonts. We have an arrow to the right, chevron to the right, chevron to the left, arrow to the left, a branch symbol. This one is an ellipsis. It's not actually part of Powerline. It's just because I used it, I added it to the code, and so it ended up on the slide. And a little lock. I'm not using the lock symbol, but yeah, one could imagine use cases for it. So first task was to find the correct Unicode code points. So how font rendering works is you basically have your font engine, you give it a code point and hope that it will render something that resembles what you wanted on the screen. So I had to find the Unicode numbers for them. The little side note on the font files, there's also the best possibly available font in there, the Go Mono for Powerline, so the Go original font that was specifically designed for so that Go code looks good. So I just put them as constant in my codes, as constants in my code. That's the whole symbol package. So symbols package. Second step was to make it easier to print out colors. I could have used existing packages. I didn't want to. I wanted to keep it simple. But in hindsight, there would have been a problem with them anyway. So I'm glad that I didn't. You can see how there's an example of a power line. You can see we are just basically switching the colors in a sophisticated way so that that arrow looks like it should. So you have in the first segment you have a black foreground and a green background. You can see. So the first arrow needs a green foreground because the symbol itself is the shape, and a gray background. So the next element has a gray background, so we also need a gray background. So the next element can take over with a white foreground and a gray background. So and so on. So you can basically chain those up, and from the two neighboring segments, you can find the color combination you need to use for the connector. So I wrote a little code. To generate this color encoding. It's basically just I have a color type and a formatting type. Both are just bytes. And I have a render function. I've omitted the actual color constants. There's a list of them, but basically you pass your foreground color, your background color, and possibly formatting options into this render function. And what it does is it gives you back a string with this escape sequence. So 033, that's I think 33 as a byte. Then this opening brace here is 0, a semicolon, the foreground a semicolon, the background, and then possibly also additional semicolons with formatting options like bold text or italic or blink, while blink isn't supported by most terminals anymore, which is very sad. Yeah, and this all ends with an M. Here you can see a small trick, so I don't have to duplicate the color codes for foreground and background. If you add a 10 to the background color, you can use the same numbers as for the foreground colors. So colors done. That isn't working. So then I needed to create some kind of abstraction. So I wanted, I don't want to handle the actual transitions between the colors and copying colors here and there and taking them from two segments or something. So I just want to have a function I can put a list of segments in, and it will basically give me the string back that contains all the color formatting, all the color codes, and the right characters at the right positions. This is done in a little bit more sophisticated way, as I just mentioned before, because when you have two segments of the same background color, it will not insert a full arrow because the arrow wouldn't be visible. It would be the same color against the same color. Doesn't make sense. So instead, it would use this chevron symbol in the foreground color to separate those segments. The segment itself is really simple. I thought about allowing the user to add their list of formatting options, but it turned out for my needs, I just needed bold. So I inserted a Boolean for that. And as you can see, it's really simple. It's just the text you want to display. It's the foreground color, the background color, and everything else is handled by this function. Also spot the bug. So what this does is basically it renders the first segment up here, and then it iterates over the rest of the segments and inserts the separator. In this case, it compares the two background colors. If it's the same, it just inserts a thin separator, that chevron, and otherwise it will insert a full separator with the proper color set. And yeah, it will process the formatting and write it out as a properly colored segment. And that will just end up in a strings buffer, and in the end I'll render out the buffer. I'll call the string method, and I have the whole the full power line basically rendered. So what remains?
We have a first candidate for a bug.
Yeah.
You want to listen. So there is sex of I, and it might be, and we have S, which is probably sex of I too, and shouldn't it be I minus 1? Is the question, because you start iteration from...
Yeah, that's not a bug. That's actually I'm using some a somewhat confusing piece of code here, because if you look up here, the range begins at 1, so this is already shifted by 1, and so index 0 points. So if I is 0, then I'm actually referring to segments 1. So when I compare these two, I'm using segments I, which is, for example, segments 0, which will then point to the actual first one, the one we rendered up here. And S points to the one we are just processing. It took me quite a while to get this code right. I also had this like I minus 1 and then plus 1, and at some point I realized, wait a minute, I'm subtracting 1 here and I'm adding it back again, so it makes no sense. Yeah, it's nasty. Sorry. No. And any takers? Do you know what's wrong? It's actually I'm not doing the formatting. The first segment can't have bold text. I realized this while I prepared this presentation. The code is still in the package because I'm doing it separately here. This code is never called for the first segment. I don't know why I missed that. I probably even wondered at some point, why can't the first segment be bold? But I don't know. Yeah. Okay. So yeah, we can render a beautiful prompt. Now let's fill it with content. So I thought about which segments I need. So most important, of course, the path. And user and host, that's one of the standards. Like in a normal prompt, you'll have those two. And but the beauty of those Powerline prompts is always to have additional information. So I added a package to basically find if we are in a Git repo and display which branch we are on. And I also added a venv thing, which doesn't really work. Like virtual env tends to put a little marker in front of the prompt, which I can't remove, at least not in ZSH. So in Bash, I found a way around it, but for ZSH, it doesn't work. So I need to redesign it. Looks a little bit weird because the first segment doesn't start with an arrow. So if there's something written in front of it, there's just a hard edge and then the power line, which it looks weird. I've pasted you the code here for the Git segment. As I mentioned, I didn't want to call any external commands. So I needed to find a way to detect where we are, if we are in a Git repo. And that's actually fairly easy because you can just go up the chain of directories and look if there's a .git directory in it. And if yes, if there is, you can read the head file. That's what read head does here. So basically, we are just checking: is there a Git .git folder in the current directory? And if yes, we read the head file. If there isn't, we try to get to the parent of the current directory, and if the parent is the same as the current one, that's a property of filepath.dir. Then we are in the root. Basically, we can't get much higher, so we break out and return an empty string. And adding that to the prompt is actually fairly easy. So we are we've got an add function here that takes a list of segments and returns a list of segments. We are not just appending always, we can also insert like in the middle or delete one of the segments if we detect that it's empty or whatever. So we are basically we are trying to find the repo. If it's not found, we just return the same list again. And if it is found, we generate a new segment, dark gray foreground, yellow background, and in bold. And we also include that branch symbol, so it looks fancy. And then we return it. So last but not least, we activate our newly developed prompt. I've named the project GoPS rather unfortunately, because there is a famous GoPS project already by Google. I know I'm probably more important than Google, but people tend to disagree. So I'll have to rename it in the future. So what we are doing here is we are setting the prompt substitution, the option for prompt substitution that's necessary on ZSH, because otherwise it will evaluate our prompt once and then never again. So it seems to work at first, but it doesn't change ever. So we have to add this, so the prompt will be evaluated every time. And in the second line, we just set our prompt to the call to our project. In this case, I started on Bash, so I added later the option to set the defaults for a specific shell. And then we try it out, and it works almost. There are, if you look very closely, it looks good. Like there's even a note. It detects a note. The note modules folder in my root folder. But there's some strange things here. So in the third prompt, there is a missing space here, and suddenly there is there is basically the complete prompt missing, and here's half of it. So what the hell is going on? And here again, so there's something strange here. Half the prompt was cut off when I pressed tab here. There's something's not right. So let's try it at bash. Oh my God. This is completely destroyed. There are parts that seem to render okay, but then there are parts that don't at all. And basically, if you write something, you write in the middle of your prompt. So so something is still wrong in our code. So we have three suspects basically. We have the Powerline font itself that may be somehow interfering with our rendering. We have Unicode, that there's something strange with Unicode. Unicode tends to have weird characters with weird lengths, like characters with a length of 2, or even characters that are rendered as one character but is 3 bytes long, or even multiple Unicode characters that are concatenated into one. So maybe that's the problem. Or the third, what could be that something's wrong with our colors. But let's go through. Also, a short, info or tidbit like this. Sometimes this works. In Bash in the GNOME terminal under Ubuntu, it looks perfect until the line gets too long. Then it just is garbled. On macOS in iTerm 2, this looks completely unacceptable. Sometimes, but on the other hand, on Ubuntu, the ZSH version looks completely weird from the start. So there's something going on. So I set out and tried a few things. I tried to replace the font itself. Maybe there's something wrong. I even replaced it with the original font, where it will just render those empty boxes. But it didn't help. It was still garbled. So I came to the conclusion that it wasn't, in fact, the font. So second thing to try to replace all those fancy Unicode code points with ASCII characters. And it didn't work either. So it had to be the colors. But that's weird, because colors usually work. Even when you have a program and you print out colored text, it just works, right? It doesn't garble your whole output. And then that's where I fell into the rabbit hole. Oh. Okay, so what are terminals and what are shells? Those are not the same, although sometimes the terms are used interchangeably. Terminals used to be hardware that you would attach to a computer via either a serial connection or even a telephone line. So you could have your giant computer, like the room filling kind, somewhere and dial in with your terminal. This, what you see here, the DEC VT100, I think VT stands for virtual terminal. That was already an evolution of this principle. The first ones had printers instead of monitors. That's also why we still call it print, like format.print line thing. They would just do that. They would print. The evolution of that was those terminals with a monitor. You can see the keyboard was always there. And basically what they do is they receive commands from the computer, or text basically from the computer, and display it. And when you press a button, it will send a signal to the computer. Or there are two modes. There's also a mode where you write the whole line and then press enter, and it's delivered to the computer via the phone line. So since these are discrete machines, or were discrete machines, and the current terminal emulators, that's what our terminals are now, they didn't have any grasp on, the computer didn't have any grasp on how the text was output. So it didn't need to, because basically there were those terminals and we would send text. But with the emergence of displays, we could do fancy things, like we could move the cursor back and overwrite a line, or move the cursor up and overwrite a previous line. And so special codes, escape sequences, were added that the terminal could interpret. The same thing for color. When we would output color, as you've seen in the code before, we are putting an escape sequence there to set the foreground and background color, and even the bold text. But now we are sending things that are not displayed, actually. And this works fine as long as the shell itself, the program running on our computer, does it. But if we suddenly print out strange escape sequences, the shell that needs to keep track where the cursor is for our prompt doesn't know about them. So the shell, the piece of software running on the giant mainframe, keeps account where the cursor currently is, but the terminal that actually does the printing ignores some of those characters, so they get out of sync. And this is not a new phenomenon or something. This is this discrepancy between what is rendered and what is provided by the computer has led to interesting problems in the past. So the first Unix versions, for example, if you connected to the computers with certain terminals which were too slow, it would just print garbled text. And they found a genius solution. They told you, if you see the garbled text, press a special combination of characters on your keyboard, and the Unix login prompt would recognize the characters, but in its own way garbled, because they were sent too slow, as I need to switch the speed of the interface, and then it would work. So it's just a little little thing I learned while researching this. These terminals and computers, they were always some problems between them. Yeah. So what is going wrong? We are sending the color codes to the terminal, but the shell interprets these codes as normal text. So they disagree where the cursor is. And when, for example, a new line is generated because the line is too long, they both disagree where the line now is. And suddenly the cursor is moved by the shell to a position where the prompt is rendered already. So basically, that disagreement is the great problem, but there is a solution. We can tell the shell to ignore certain characters when counting. There are a few codes for this. So that backslash braces basically you can use them. They will not be rendered by the terminal, and they will be interpreted by the shell to mean, ignore this when counting the position. Also ignore certain other things in there, but that leads too far. So I tried it, and what the hell, bash? Turns out, yes, those exist, and those work perfectly in bash scripts, for example, but not in prompts, because the prompts are handled differently. They are not interpreted the same way. So we need to use the binary version of those escape codes in bash, just in bash. So we have to use the bytes 1 and 2, which you can just write into your output, and they will have the same effect. And with that fix, I managed to get it working. I learned a few things while doing this. So the interaction between shells and terminals is a lot more complicated than I imagined. I always thought it was like, the terminal is the window and the shell is running inside it. But I thought, they closely communicate, right? How else would they print something on your screen? But really, they don't. It's a layer cake of legacy protocols that is used. But it has one advantage. You still, to this day, can pipe output from those old mainframes or computers to your terminal emulator, and it will work for the most part. For example, at work, I'm using a lot of embedded hardware. And when you attach a debug interface and just pipe the input and output from the debug interface to a terminal, to a terminal window, it will just work. It will work as if you were, if you had a keyboard keyboard and monitor attached to the hardware. So there is a reason for this, but it introduces a lot of pain. Also, there are even today incompatibilities between the shells and the terminals. So there are terminals that work better with certain shells. There are shells that don't know about the specifics of certain terminals and will send escape sequences the terminal can't interpret. So you have to try it out, basically. There are sometimes documentation. There's sometimes documentation on which works best or something, but most of the time, just try it, basically. Which leads me to the next point. There is often a complete lack of documentation. So the trick that you have to put a 1 byte or a 2 byte in the if you are trying to render a prompt in Bash. It took me hours to Google that and try out different things, and you have to be really, really careful, really good. Like your Google magic has to work, so you can really make sense of it. But in conclusion, hacking your own shell, your own prompt, is fun. Now I can, if I have a new thing that I want to display it in my project, I can just put it in my own prompt creator, my prompt program, and it will just work. I encourage you to keep hacking, do the same. Maybe write a completely different prompt implementation. There are plenty different now out there that will give give general information about the environment you're currently using, the project, and so on. It's really impressive. And yeah, thank you for your attention.